Alright, today we're going to go over 3.3 homework, part 2, page 184 to 185, 22 to 44 even. Alright, for all the problems 22 through 26, you need to know that f of x is 3x plus 2, g of x is negative x squared, and h of x is x minus 2 all over 5. 22 is a composition. A composition means you have a function inside of a function. So I always start with whatever I see first. I see that h first, so I write h a big old blank space. Because I'm just going to ignore that f of negative 9 right now, because that's kind of the hard part. So because I see h, I go back and look at my function. I'm going to use this one right here. All right, that's the one I'm going to use. So I write, instead of x, I write a blank space. So I put blank space minus 2 all over 5. Now, I'm going to put in f of negative 9 right here. And if I put f of negative 9 in right here, I have to put it in my blank space. Alright? Now I look at f of negative 9. It kind of looks like f of x. And since f of x is 3x plus 2, when I make f of negative 9, I just replace that x right there with negative 9. So I put 3 times negative 9 plus 2. A lot of times, everybody they'll just replace they'll write h of f of negative 9. And instead of f of negative 9, they're just going to put 3 times negative 9 plus 2, all minus 2, all over 5. Now I do the top. The top is 3 times negative 9, which is negative 27. Negative 27 plus 2 is negative 25. Negative 25 minus 2 is minus 27. And the bottom is 5. I keep this at the end because that's my label. So my final answer should be h of f of negative 9 equals minus 27 all over 5. That's it. Alright, so 24 is h of g of 5. Once again, I see that h, so the first thing I do is I write h, a big old blank space, and instead of x, I write big old blank space, minus 2 all over 5. So now I have to figure out what is g of 5. Well, since g of x equals minus x squared, g of 5 equals minus, instead of x, I put 5 squared. All right. Sometimes it's really easy. It's a little bit easier to put in, to just simplify this first. So I put g of 5 equals 5 squared is 25, so it's minus 25. So when I put this g of 5 in here, I don't write g of 5. I write negative 25. And I do the same thing, negative 25 minus 2 is minus 27 all over 5. And I remember I keep this at the end because that's my label. I need this name tag, so I actually say my final answer is f of g of 5 equals negative 27 over 5. And I'm done. Alright, so I'm going to do h of negative 4. So the first thing I do is I see an h, so I write h of big old blank space. So I put big old blank space minus 2 all over 5. Now, I'm going to figure out h of negative 4. That's what I'm going to do next. I'm going to figure out h of negative 4. So over here, I need to figure out what h of negative 4 is over here. This is kind of like side work or scratch work. So what I need to know is, what is h of x? Well, h of x is x minus 2 all over 5. So I put this negative 4 minus 2 all over 5. So h of negative 4 is minus 6 over 5. Because it's already a fraction, I'm just going to leave this as minus 6 over 5. I'm going to put minus 6 over 5 right here. Minus 6 over 5, well, if you didn't know what 2 is minus 10 over 5. So my next line becomes h of negative 4 equals minus 16 over 5 all over 5. That's just another way, or you could write minus 16 over 5 times 1/5, because that's the same thing as divided by 5. So my best answer is h of negative 4 equals minus 16 all over 25. And I'm done. And that's how you finish 26. All right, 28 through 34, here are the three functions they're going to give you. Since our questions have x's in them, I know I'm going to need domain later. So right away, I'm just going to find the domain of all these now, because they'll be my originals I look at the end. So when I just remember no negative exponents, so I make this 3 over x. And when I think of my domain, remember it always starts as all the real numbers. So 1 second. Now, remember we're going to go over the domain rules. And the rule is that your domain always starts off as all the real numbers. The domain is always all the real numbers first. Unless you see a fraction. Sometimes a fraction is hidden in a negative exponent. So if you see a negative exponent, think it's going to be a fraction. Remember, when that fraction shows up, the denominator can never equal 0, because then it's going to make your calculator blow up. That's why we have to worry about that. Next thing, your radical. If you see a radical, so the yellow part's like the visual cues. So if you see a radical or a fraction exponent, that really means it's going to turn into a radical. You can't have a negative in there. So that's the rule. You're going to look for that. And then finally, you check the domain of the originals, because if you were never allowed to use that domain in the first place, if you couldn't use x in the first place, then you can't use it at the end, even if it looks like it would work. So that's really what this comes down to. All right. So I'm going to find the domain of these originals. So this one, this f of x, the domain starts off all the reals, but right away I see a fraction. All right. Since I have a fraction, that bottom cannot be equal to 0. So I just say x cannot equal 0. So your domain is all the real numbers in the world except x cannot equal 0. So you're done with that one. All right. The next one, g of x. G of x. The domain starts off as all the real numbers in the world. There are no fractions. So it stays all the real numbers in the world. There's no radicals. That's why it stays all the real numbers in the world. And because it's the original function, I don't have to check anything else. All right. H of x. Once again, domain is all the real numbers in the world. Now I see a fraction, but there's no variable in the bottom. That's why it's not breaking our rule. There's no way you can change x and make that 3, 0. All right. And then finally, there are no radicals, so that's why it stays all the real numbers in the world. All right, 28, I have f of g of x. So the first thing I'm going to do, I'm going to write f of big old blank space. All right, I have big old blank space. Now, because I'm using f, I need to know what f of x is. So I go back and I'm going to look and see what f of x is. And I see f of x is 3x minus 1. So instead of 3x, to the negative first power. So instead of writing x, I just write big old blank space. So I put 3 of big old blank space minus 1. All right, now I'm going to plug in g of x. So I put g of x here. So I need to know what g of x is. So I go back and look. G of x is 2x minus 7. So I put 2x minus 7 here. Now I just do some simplifying. So f of g of x equals 3 And because that's negative, I make it, and the negative is not attached to the 3, I put the 2x minus 7 on the bottom. All right. Now I start with my domain. Domain always starts off as all the reals, or R with 2 bars. That's just a list of all the real numbers in the world. I look for my first exception. See how I see a fraction there? So I say 2x minus 7 cannot equal 0. X is going to be equal to, x cannot equal 7 halves. So that's the first thing I do, is I say x cannot equal 7 halves. All right? There are no radicals. But now I have to check the original. And I look at, so I have to check F, and G. So I go back and look at F and G. F says x cannot equal 0. So since F says x cannot equal 0, G I don't have to worry about because it's all the real numbers. So because of that, I say x can also not equal 0. Because of f of x domain. All right, that's it for 28. All right, 30 says h of f of x. So I always start with h because that's the first thing I see. So I put h and I put a big old blank space. And I need to know the original function, so I go back and I see the original function is x plus 4 all over 3. So h of x equals x plus 4 all over 3. So instead of x, I put blank space plus 4 all over 3. All right. Now I'm going to plug in f of x. Well, I know f of x is 3x to the negative first. So I'm going to put 3x to the negative first power. All right. So I end up with h of f of x equals 3x to the negative first plus 4 all over 3. Now before I go any further, I need to get rid of this negative exponent. I'm not allowed to have that there. But I also have a fraction going on. So I'm going to split up this fraction. I'm going to split it up into 3x to the negative first all over 3 plus 4/3. I'm allowed to split that up. Now the 3's cancel. This becomes x to the negative 1. So your final answer is h of f of x equals 1 over x plus 4/3. That's the function. All right? That's our work. Now I need the domain. Well, the domain starts off at all the real numbers. Because of that right there, I have to say x cannot be equal to 0, because if 0 showed up on the bottom, then it would make an error. There are no radicals. And the originals are the same or more. So I don't have to worry about checking the originals. So this is my final answer. I have both my new stuff and my domain. Remember, domain is kind of like the instructions. All right, 32, I have h of g of x. So remember, h of x is x plus 4 all over 3. And g of x is 2x minus 7. All right, 32, we have h of g of x. H of x is x plus 4. G of x is 2x minus 7. I start with h. Put h a big old blank space. So I put big old blank space plus 4 all over 3. Now I'm going to put in g of x. I'm going to put in g of x. So if I put g of x in here, I'm going to put 2x minus 7 right here. Now I'm just going to simplify. 2x minus 7, can't do anything in there, so I do 2x minus 3 all over 3. And I would just leave it just like that. So h of g of x is just 2x minus 3 over 3. You could make it 2/3 x minus 1 if you wanted to. 2/3 x minus 1 if you, but I would take either or. Now I'm doing domain. My domain always starts off with all the real numbers. I don't see a variable in the bottom, so there is no variable in the bottom. All right, there's no variable in the bottom, and I look, there are no radicals. And then if I look back on G and H over here, G and H are all the real numbers, so they're not going to change anything. So that's my final answer right here. And that's it. Alright, so 34 is kind of tough because you're going to have a fraction inside of a fraction. But remember, we start everything out the same way. I put H, a big old blank space, because I see H there. So I put big old blank space plus 4 all over 3. Now, instead of blank space, I'm going to put H of x. So I put H of x right there. Or you can immediately just write x plus 4 over 3. Now, real quickly, I'm going to rewrite 4 as 12/3. So I'm just focusing on the top right now. I'm just looking at the top. So I have H of x equals x plus 16 all over 3 over 3. You could do that. The easiest way to think of that is when you divide by 3, it's the same thing as multiplying by 1/3. So your final answer is H of x equals x plus 16 all over 9. Now you got to find the domain. Starts off as all the real numbers. There are no variables in my bottom. So that rule keeps it all the reals. There are no radicals. And then I look at my original function. All right. Since f of x says x cannot equal 0, I add x cannot equal 0. All right. So that's my final answer. And so that x is 0 added because of f of x, because that was one of my original functions. All right. So 36, they give you f of x and g of x. I'm not even going to look at what the book did wrong at first. I'm just going to do the problem all by itself. They want you to do f of g of x. So right away, I'm going to start with f of big old blank space. So I take this and I write big old blank space squared minus 3. All right. Now I'm going to put g of x in here. So that means instead of, in this blank space, I can either put g of x right here, or I can just immediately write 4x. Now remember, we're just going to simplify, so f of g of x equals 16x squared minus 3. All right. And then I'm done. I find my domain. It starts off with all the real numbers. I don't see any fractions, so it stays all the real numbers. I don't see any radicals, and I don't see that in the originals. Like if I did the domain real fast to these two, the domain doesn't have any issues either, so it's just going to stay all the real numbers. All right. Now, if you compare it to what the book did wrong, the book used both the original and so the book mistake was they used both f and g at the same time. All right, we'll talk a little bit more about that tomorrow. So that's the book mistake, because they want to know what the book mistake is for that one. All right, 38 is a multiple choice. I'm not even going to do the multiple choice part. I'm just going to do the problem. g of f of x if f of x is 7x squared and g of x is 3x to the negative second. Now before I get started, remember g of x is 3 over x squared. So that tells me right away in my original domain it's all the real numbers, but x cannot equal 0. Alright, that's my original domain. So when I do this problem, I start off with g of big old blank space. So I put 3 of big old blank space, negative 2. Right? Now I'm going to put in f of x. So I put in f of x. So I could either write f of x in here, but I'm just going to take 7x squared and write it there. Alright? So now I'm just going to distribute the negative sign, the negative 2 to both of them. So I end up with 3 times 7 to the negative second power, x to the 0 power, and I end up with 3 over 7 squared. Anything to the 0 power, anything to the 0 power equals 1. So that turns into 1. So my g of f of x just turns into 3 over 7 squared, which is 3 over 49. Alright? And then finally, I'm going to tell me my domain. The domain is all the real numbers in the world. Now, I don't see any fractions of the letter on the bottom, but the original said I cannot have 0, so I say x cannot equal 0. So that's my final answer. And that's it. So 40 is kind of working backwards. They're going to give you a function, and they want you to kind of work backwards. So they're going to give you a brand new function, but they want you to figure out a way that you can combine it to make it. You're kind of working backwards. So they're saying h of x equals the cube root of x plus 2. So you got to figure out what's going on in here. So I look for what's going on. I see an x plus 2, and I see this radical. That's two things that are going on. So the first thing I'm going to do is I'm going to say, well, I bet I should have a function where it's x plus 2, because that's what I see. All right? All right? And then I bet I'm going to have a function that's going to have a cube root. Now, I already used this part, so I don't see any letter there, but remember, since it's an x there, I am going to put an x there. So that's why I'm putting x here. Now, to make h of x, to make my new function, I have to have g of f of x, because g of big blank space is cube root of big blank space, and then if I put f of x in there, it turns into what I started with. So that's kind of the idea right there. All right, that's it for 40. All right, so I look right away and I see what's going on. So I see this. So that's the first thing I say. I say f of x equals 2x plus 9. All right, and then g of x is what else is going on? Well, I see absolute value bars. Now normally I would leave a blank because I already used 2x plus 9, but because I have to have a variable there, I just put x there. All right. Now, if I did f of g of x, I would get 2 times the absolute value of x plus 9. That's not what I want. I want this. So I have to do g of f of x, because g of big old blank space is absolute value of big old blank space. And then if I put f of x in here, I get 2x plus 9. Now I have the same thing here. All right, that's how you do 42.